Okay, we're on the final stretch, the last 37, last 7 of 37. I'm very excited because I'm getting really tired of doing algebra 2. I don't mind telling you. All right, so the solution to a quadratic equation is negative 16 minus 8i squared root of 35. Which of these must also be a solution? Okay, remember that imaginary numbers, imaginary solutions, imaginary roots, whatever you want to call them, imaginary, we'll call them roots. Zeros, not really zeros, but imaginary root solutions come in blank. The answer is pairs. They come in pairs. Okay, and you're looking for the one that has the opposite sign of this one right here. Okay, so look for negative 16 plus 8i squared root of 35. Looks like this guy right here. It's called, vocabulary-wise, it's called the conjugate. You're going to use the conjugate when you have questions like this. You're also going to have a conjugate. You're going to use the conjugate if they ask you to get rid of radicals on the bottom or i's on the bottom. You're going to use conjugates. Okay, so that's an easy question. So whenever they give you one of the two imaginary roots, the other one is very easy to find. Okay, I'm going to change colors. I'm really getting sick of red. Alright, so it says here, assuming the denominator does not equal 0, completely simplify the following expression. Alright, so this is all about factoring. So, let's see. This one's pretty tough. I don't really like the minus 2 starting everything off, so I'm going to take a negative out of that. Because my brain is used to doing, and again, if I take a negative out, all my signs change. Okay, I don't like having a negative in front of my x squared term or my d squared term because that just messes with my mind. And this guy, if I wanted to, I could, if you take out a negative on that one, it allows you to turn them the other direction so your brain can handle the difference of squares. It looks kind of weird. It kind of looks backwards. So if you notice, what's a negative divided by a negative? It's a positive, so these guys I don't have to worry about them the whole rest of the time because they kind of cancel each other out. Times, because you can only multiply rational expressions, and we're going to turn this over. So the 4d is going on the bottom here, and I can't factor that, so yay for us, we don't have to do that. And then I've got to factor 2d squared plus 11d plus, why is we having so much problems with this? Plus 15. Alright, so I've got a couple of things to factor. So I'm going to go over here and factor this first one. Alright, how do we do this? So let me use I'll use green. Alright, so I'm going to multiply these two things. Make a big fat X. Okay, the top number is the middle term, which is negative 1. Okay, there's a negative 1 right there. And then I'm going to multiply these two, and that's going to give me a negative 30. Alright, I'm looking for two factors to give me negative 30, but add to give me negative 1. That's going to be negative 6 and positive 5. Negative 6 plus 5 gives me negative 1, and negative 6 times 5 gives me negative 30. So those are the two I'm going to use. So when I write my factors, the thing that's a little bit confusing about this is you're going to write your factors down. Now, whoops, I'm supposed to be using D. Let's undo that. D minus 6 and D plus 5. Now remember, what did you multiply at the beginning? You multiplied by 2, so you have to remember you got to divide these back out by 2. So this, because I don't have a lot of room, let me erase this little arch here. Okay, if I finally get a chance to write this stuff up, if I can divide by 2, I do. So this is going to be D minus 3. Now if I can't divide, I'm going to shoot this in front of the D. So this is going to be 2D plus 5. Alright, that's factored. This one's an easy one, at least it should be easy. If not, then you need to do a little bit more work because these are gimmies. The ones with the perfect squares, you got to recognize that 9 and 16 and 25, those are all perfect squares. They don't usually make them very big, but you got to know them. Alright, now I got to do the same thing over here, so let me use some room. Alright, so my middle number goes here, and then I multiply these two, which gives me 30. Two factors of 30 to give me 11. Well, that's 5 and 6. So I'll do the same process as I did before, and let me erase because I need the space. Alright, I'll find out the two factors, which are 5 and 6, and then make sure I divide by 2 if I can. So this one's going to come out to be 2d plus 5, and this one's going to be d plus 3. Alright, so now everything is factored the best I can. Let me put this in parentheses to remind myself it's factored. And now I'm going to go to town and cross stuff out. So let's change colors. Alright, so let's look. And the rule of thumb is whatever is on the top can be crossed out with something on the bottom, and that's it. So I got a d plus 3 and another d plus 3. I got a d minus 3 and another d minus 3. And it doesn't look like I can do anything else. Alright, I don't want to cross out these two because they are on the same level. You can't cross these out. So I have two of these, and notice that's what this is showing you right here. I've got two of them. So this guy belongs here. So this is going to be, again, a drag and drop type of application that you're going to do. And then I've got this 4d plus 1 I didn't do anything with either. So that's what's going to go on the bottom. And you're done. Whew, alright, so now we got to do this big ugly thing. So what we're going to do on this, I think I've done one earlier in the, it says select two answers that are correct. Okay, so let's see. Okay, so what it looks like to me is they want it in radical form, and then they want it in exponential form, like little exponents, like fractional exponents. These are definitely wrong. Any of these where you've taken 729 and divided it by 6, that's bad. So all of these are not good. Those are just crap. Because you're going to take the 6th root of 729. You're not going to have all of this. Okay, so all of these are just distractors. So we're looking at these three things right here. Alright, so let's break up the numbers, and then we'll break up the letters. Alright, 729. Break it up any way you can. Let's see, let me do 9 times 81. Alright, so 9 times 81. Okay, so I'm going to take out, let's see, a 3. Let's see, a 3. Oh, I'm going to have lots of 3s. 3, 3, 3, 3. 2, 4, 6 3s. Alright, hey, that's good because look at all of these things have 3s in them. So that's good. So 3's coming out and there's nothing left of the number. Alright, so that's good. Now we have to do the 6th root of Q17 and R11. Now the best way to do this one is to think about the fact that when you have an exponent, it just tells you how many. So instead of having to break them up like I did here with all these 3's, this tells me how many Q's I do have. This tells me how many R's I do have. So I have 17 Q's. Now I'm not going to write them all out, but basically I'm looking for groups of 6. Well, how many groups of 6 am I going to get out of 17? I'm going to get, let's see, I'm going to get 12. I'll pull 12 out of that. Yeah. I'll have squared because I'll have taken 12 out. Remember, group of 6 and another group of 6, so I'm using 12. I still have 5 of them left over. So that looks good. That's looking good right now. R to the 11, groups of 6, I can only take out one group of 6, and I'm still left with 5 of them. So throw that 3 in the front. And that looks like this guy right here. Now, what we have to figure out is they want something in radical form. So what they're doing is they're going to take, looks like, let's see, these are the same roots. Alright, so see this one before we broke it up? That's the same thing. All they did was take the 3 out. They left this one alone. See how this has a 17 root 6 and an 11 root 6? That's the same thing as this one right here. Okay, so that's also correct. Those are two correct answers in radical form because I can't reduce these fractions any. So technically this is right and this is right. This one is in radical form, exponential form. And all you have to remember is if I had a letter or a number, the top part of that is the power or raise, and the bottom number tells you to root it. And so if you look at this, this has a 6th root. That's why these have 6's. Okay, and then the exponents, these are the raise or the powers. They're up top. Okay, and that's how you do that problem. Alright, so it looks like I have to clean this up again, and again I want you to think about the fact that this is just a division problem, an ugly division problem. There's a division fraction line there, so I'm going to write it um, long ways because I think kids understand it better if we do it that way. So we're going to put 42d cubed, we're going to put times, because remember we can only multiply, and I'm going to flip this over while I have the chance. 13 minus d. Wow. The tablet is freaking out because I've got so many other things running. Alright, so let's see. Can I do anything to this? What if I take a minus out of this? I'm going to be left with a 13 minus d. Well, that looks an awful lot like that one. So let's go crazy and cross out some stuff. So I can cross out this one with this one now. I've got a minus. Just remember I have a minus 1 sitting out here, so let's not forget about it. Okay, can I reduce this at all? Yeah, I can. 6 goes into 6 once. 6 goes into 42 7 times. Also, I've got 3 D's and I've got 9 D's. So this goes away and I'm going to be left with 6 of those. So leftovers looks like negative D. If you want to put the 1 there, you can. 1D to the 6th all over 7. Hopefully I've got one that looks like that. It sure does. And that's D. Woohoo! Alright. We're getting there. We're getting to the end. Alright, so this one, I'm not even sure if they do these anymore. Piecewise functions, they're called, because they're in pieces. But they do, I mean, I guess they legally could ask this question because it is a domain question. It says, what appears to be the domain? So what x's makes this thing even happen? So what you're doing is you're looking at the x-axis, and wherever you see a graph, make a mark. Okay, so, and I'm going to start making, as long as I see a graph, I'm going to keep a mark going. Ready? Here I go. Okay, still see a graph, still see a graph. Even when I get to this dot, this one's still got a value that goes in there. It's dot, 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 dot. Okay, I don't see any more graph. So I would stop this right on the 2 because I have nothing else, no other graph here, and I have no other graph there. So all I have to do is describe this. I have to describe all the x's, and that's this guy right here, and you're done. Okay, it just wants to know what x values will create this crazy looking graph. And basically, as long as you see a graph, just keep your pen or pencil or your highlighter, whatever you're using on the test, just keep it along the x-axis as long as you see a graph either below or above the x-axis. As long as you see it. As soon as you stop seeing graphs, stop drawing, and you'll have the answer. And this is all this is saying is x is stuck between -5 and 2, which is what this is describing. Down to the last 2. Alright, so which of the following describes the end behavior of 9 log 2 to the 5th x plus 5 as x approaches 0? Alright. Now, let's see. My first question to you is, do you know what the parent graph looks like? Alright, so let me show you what that looks like. Okay, here's my parent graph. Here's my, let me put in my asymptote line, which is kind of running along here. Okay, and this is my x, my y, and my x-axis, just to let you know. And my parent graph kind of does this. It goes, here's 1. Okay, my parent graph gets really close to this, hits that, and then kind of goes off like that. It's like really steep, and then kind of, it's still rising, but not as much. You know, unlike the exponentials, which starts out really thin and then kind of shoots off that direction. Remember that they're inverses of each other. All right, so what my question is did I do anything to make this thing really move to the left or to the right? And the reason why I say that is because the 9 makes it stretch, it stretches it out a little bit wider, I mean a little bit longer, so it would look skinnier to us. This part moves it left or right, and if you notice, that's still not moving it to the left or to the right. There's no plus and minus in there to add or subtract or move it from left to right. So that's not changing it any. And then this guy moves the graph up. Alright, so but does up affect my asymptote line? So what it's saying is x is starting to approach, let me use my little thing here is x is starting to approach 0. So here I am. It's starting to approach 0. Here I am. I haven't made it there yet, so pretend I haven't made it there yet. What is this thing doing? It's going closer and closer and closer. It keeps going and down, 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 down. So where is it approaching? It's approaching negative infinity. It's down here in the dark depths. This is positive infinity with the y's, here's positive infinity with the x's, and negative infinity with the x's. So in case you needed that, there you go. So look, you can see what the arrow points are doing. The arrow points are pointing towards the negative infinity, which is where it's headed as x approaches 0. Okay, and what do I got left? Whew, the last question. Yes, and it is a properties question. So you got to know your properties pretty well in order to answer this question. So we have to just compare. Again, you look at step 1, which is right here, and you're going to say, hey, how did I get from here to there? What did I do? I think that's part of a Sesame Street song. How do you get from here to there? What do you do? Anyway, so I'm going to look at these things and see what did I do. All right, well, that matches. That's over here, that's over there, so I move the order around. That's going to be the commutative property. The way you can remember commutative property, see that those first two letters? CO means change order. Okay, so commutative property always change the order, CO. Commuters also, they go from place to place, that kind of thing. Alright, so how did I get from this one to this one? Well, these compare. All it looks like I did was add parentheses. So if I just am adding parentheses, that's going to be the associative property. Okay, so that's going in here. Alright, and then it looks like I took the i's out. Now that looks like factoring. But factoring is not an option. Believe it or not, this is the distributive property, but not the way we're used to seeing it. We're used to using the distributive property to put things in, not take things out. But it works both directions. And then substitution, I don't have to do anything because it's the answer. So there you go. That's all 37 problems. I hope you learned something because I'm exhausted and good luck. This test is not going to, it's not really that hard more than it's very thorough. It's asking you to do a lot of things per problem, and especially these where if you miss one thing you get it all wrong. It's kind of, it's bad, but I think you'll do fine. Good luck.